start recording. Hey everybody, this is Payload Pat, and this is another K8's Cadence session that we have. We wanted to start off the year, nice, and we got quite a bit of crew here, so we got quite a bit of people. So thank you all for joining. So what we're doing today is we're creating a cluster, a local cluster. It's going to be you can have how many nodes you want, but we're just going to do a simple kind cluster, which has one control plane and two worker nodes. And we're going to be deploying a Flask application. First, we're going to Dockerize the application, then we'll containerize it, and then we'll be able to go ahead and run it on Docker locally. And then I want you guys to see how it will look on your Kubernetes cluster, and then we can do some fun things like changing environmental variables and all that good stuff. So just to get started, I think this was a good point for us to start the year off with, and then of course we can go ahead and improve and make our changes. As far as the topics and subjects. So that's where we're at now. So I shared my GitHub here in the chat, and it pretty much just gives you instructions on how to set up your first cluster using kind. And it's literally only a few commands that you need to do to do the installation. So if you haven't checked that out, I actually have another video on YouTube as well if you want to see that process. But in the for those who are in the meeting now, if you're having any issues with setting that up, please let me know so we can go ahead and troubleshoot for you. But has anyone completed that yet, or how are we looking with that? Because I don't want to move too fast. And again, don't be afraid to speak up. I don't want you guys to feel like you're falling behind or you're confused at something. So this is a safe space.
Yeah. Anybody gonna talk tonight? Anybody got mics?
There's a lot of new people, so I don't want you guys to be afraid or nervous or anything like that.
Oh, that's cool. Especially we got like some new people. It would be nice to know what level everyone is at. You know what I'm saying?
Yeah, guys. Okay. I'll talk. No problem.
Okay, cool.
Oh, that's TJ. What's up, TJ?
Nothing, man. Over here trying to mess with this stuff.
Bye.
Cause I ain't open. I haven't opened my home brew, so I'm trying to see am I even running on. I'm like, I gotta check something on Linux. I'm like, I don't even remember. Like, I
uh,
haven't even used it because I've been in Code Cloud, so I haven't even used it like that. So I'm
no,
trying to
you're
verify.
good. You're good. And Code Cloud is still good to use. I just prefer us to have something that we can test and not necessarily have to have a
Well, I
uh,
used to run on a virtual machine, but I haven't been doing that. I
yeah,
didn't
we don't do
experiment.
that. Don't do that, TJ. Come on, man. And that brings up a good topic, I guess, for those who are
Hmm.
um new to like Linux and stuff, what the difference is between like a
Mhm.
container, and why not just run something on like a virtual machine? Um, does anybody want to take a crack at that? Or like why? Anyone want to go over what's the difference between the two?
Yeah, I can do that. I do
Yeah,
more so of an analogy, though. I'm good.
yeah,
This is
yeah, that
Brenton, by the
works.
way.
That'll do.
So let's just say you are in a home, and you pretty much homes have like sections. You have rooms and things like that. So you have your room, and your brother has his room. Those we could, and then those rooms have their own like bathroom, may have their own kitchen, things of that nature. It's its own separate place to where that is your separate space. Those
Hmm.
more so like a virtual machine to where it's utilizing a space, a separate space that is still used to live in, but and do other things, but you still is in within the same, host of a home. A container is more so like a box. So you have a separate box that only is used for a particular type of, like you have a toy box. And it's only used for that, to where it only like house your toys. And so it use a smaller compressed space, that is only used for that particular thing, while as a room it utilizes like more of the resources. Like you still utilize the lights, you still utilize the water, it still utilize things of that nature. When the
Hmm.
container only just use like that one space, and then it houses the one toy. That makes sense.
Okay, no, that's a great explanation. And um, a container is still a VM in a way, just one level more abstracted than a VM, which is one level more abstracted than bare metal, which is absolutely true. And essentially, the difference between the two really is, yeah, it's one is at the level of the like the operating system, and then one is at the level of the actual like what is it, like the physical like machine. So like one is virtualizing the host like operating systems, because a container, for example, you would have to have a um it pretty much would have to have its own operating system, and you would have to manage and control that. The container is more, you know, controlled, where the it's not really worrying about the operating system. It's using the same kernel, but they are separated in this form of Linux because there's this thing called like they're different namespaces. So you can have a container running, and it doesn't know about any of the processes on the host machine. However, on the if you look at like the actual bare machine, is the bare metal host that we're using or the node that we're using, it will be able to see all the processes that itself is running, as well as the virtual machine. So there's a separation. The container doesn't know anything about anything else besides its own stuff. So it is siloed, as you mentioned, as far as its only toy in the box. So sometimes it can be confusing, but the main premise of a container is you pretty much have everything you need, all the dependencies that you need, packaged in one thing. So you don't have that issue of where people used to say it works on my machine. It pretty much doesn't matter what machine you run it on. You can run this on, you know, on prem, on bare metal, like you all, like a lot of you all mentioned that you have. You can run it on the cloud, you know, like a hosted like EKS, Elastic, you know, Kubernetes service, or you can run it on Google Cloud engine, and that can be ran also on the edge as well. So there's a lot of different varieties of ways that you can run containers and Kubernetes on. And what Kubernetes is just it's an orchestration of that. So um, as far as at a high level, um, how can I say this? Yeah, so it's an open source platform, and it's pretty much set up and designed to like automate scheduling, deployments, and and application containers, as we'll see in a minute as well. So first thing that we were going to do here is set up a simple, very simple Flask application that we can actually access from my GitHub account. So if you guys just and I posted this in the chat, right? I hope. Um, did I? I'll post it again if you guys didn't see it before. But that's just the kind install section. I should have mentioned but go ahead and if you guys can, let's pull or let's do a clone of this repo so you can just have it locally. I've done it already, but to do that, all you need to go is to the main page here, and you can just click code and you can click clone here. So you can just do git clone and it'll be like git clone and then paste it here, and then you'll be able to download everything. But I already have it here, so I'm not going to do that. But you should see this here when you do. So you should see README, Flask App v2, v3, kind install, and metric server. But we're only really focused on the Flask app for now. So we can go ahead and migrate to CD, Flask app, and it should have a couple of things in here that we'll go ahead and discuss and talk about what this is. So has anyone not Dockerized or containerized an application before, or has like no idea what that even means? Because again, I don't want to make any like assumptions that everybody knows what that is and stuff.
Um, I have not done that before, so
You haven't? Okay,
yeah.
awesome. Well, that's cool. That's cool. Um, and what we're doing is pretty much we have an application here called app.py. It's a very simple application. In fact, I'm going to, you guys can stay on this here, but I'm just going to go back because I made some changes that I probably shouldn't have done. But I want you guys to see this here. It's going to be called is it what, a Flask app version 2, v2, right? And let's cat the app.py. And this is very, very basic, but it's a Flask app that literally just says this here. Hello, username, welcome to your Cadence app, right? And you guys can even ignore this because it won't really show anything now, but this app is running on pod, whatever. But these are all environmental variables, and I'll be showing you guys how to, display whatever you kind of want on there. But essentially, what we're trying to do is just get this application um, Dockerized, and you guys should be able to see it on your local host. So that's going to be the plan. And if you haven't done it before, it's okay because we have everything that you need to go and get it done. So I'm going to go back to the main Flask app here. And what we're going to do here is I'm going to cat this Docker file, right? So we see we have our application, and then we also have this thing here. Actually, let's do cat requirements. So this is pretty much saying in order for this app.py to work, it needs these particular like resources and pretty much these are the dependencies that it needs to run, right? So what we're going to do is we're going to package the app.py as well as the requirements all into one package. So the file, the Docker image that we're going to create is going to have everything that we need as far as the file systems and everything for this application to run, right? So we have this thing called a Docker file. So if I do a cat Docker file, it probably looks like overwhelming, especially if you've never seen this before, but it's all right. So the Docker file pretty much is a list of instructions that we're telling Docker to go ahead and do X, Y, Z. So it's starting from the top from Python 3.9-slim. So from this image, this is the baseline image that we're using. We're going to go ahead and set a working directory in this container. So the working directory is going to be /usr source app. And this is just saying we're working inside this directory. So when a container starts, it's using this directory. This is where we're going to be putting the app.py stuff in, right? So it says copy dot space dot. Like, when the hell is that? So this is pretty much going to copy the current content. So the current content in this like directory the into this work directory in the container, right? So from here, from locally from my computer right now, I'm going to go ahead and copy this all the stuff in here inside this directory in the container, right? Once that's done, I'm telling it to go ahead and run or do this command, run this command. So run pip install the requirements. Remember we had that requirements page. So it's going to actually install the Flask dependencies and the other dependencies that I had in there as well. And this is all pretty much doing that in the container. So the image itself is going to have all that stuff packaged inside of it. Once that's done, it's going to say, hey, I need you to expose the port 5000, which is going to be available outside this container, right? So expose port 5000 and make it open. So someone reaches this application, they're able to actually see the web page that we have in the app.py. And then I also added this environmental variable named username is equal to user. So that's just going to be the default. If we don't add any environmental variables, which I'll show you later when we actually try to run this Docker image, it's going to pretty much run, it's going to pretty much show user as welcome user in the application. And then at the end of it, it's going to say, hey, run the application. So run this command, Python ./@py. So that's just saying, hey, once the application is started, once the container is started, what should it do? It should go ahead and run the app.py, which is going to go ahead and then, display the content that we had showed in the other in the app.py file. So hopefully that kind of explained what the Docker file is. All it is literally is a set of instructions to do XYZ, and that was going to create the image. This is the image. A container is literally a running image of, is a running image essentially. So that's the jargon of a container. It's just an actual image that's ran. And an image is simply, a packaged set of dependencies and instructions, for, you know, what your container or what your application is meant to do. A container has one job. It has a job of doing something, a process or something. In this case, it's just go ahead and displaying a web page for us. But again, it can be a variety of things. It can run batch applications. It can do a particular job. It can run a specific set of instructions or tasks that you have it do. So again, container has a particular process that it needs to go ahead and complete. And then it's done. So anyone have any questions so far before we go ahead and start actually building this image? Because I want you guys to do this on your computer so you can actually see this process end to end.
Hey, I got one quick question, PJ.
Yes, sir.
I think I kind of stepped away. Is that project it's up on the Flask app, right?
Yeah.
You said just clone that down. All right, I'll do that and catch up. No big
Yeah,
deal.
just clone it. Yeah, clone it and then just go to the Flask app folder and you should be good to go.
All right, appreciate it.
Yeah, I won't be able to do. I forgot to
Yeah,
install Git in my virtual machine, so I'm just gonna watch. But
hi.
yeah, I have your GitHub. I'm just gonna clone it whenever I get a
Okay,
chance
cool.
to.
That cool. That works. I think someone else is going to say something.
Yes, yeah. I think the last speaker. I actually wanted to say it might be a bit difficult to follow you since it's recording. It's recorded. We
Yeah,
might probably do it again before the next class.
that's
I
fine.
think
That's
that
fine. That
that would be
works.
cool. Yeah. All
Yeah,
right.
it's,
Thank you.
it's no worries at all. Don't feel that you're left behind. But definitely the best way to learn is to try. You can watch a million YouTube videos and videos in general. But if you don't try yourself, you're not gonna hopefully you're not gonna really grasp it. So I just wanted to be a cool, fun way to
Hey,
learn containerization and
Patrick,
Kubernetes.
Patrick,
Thank you.
hey, Patrick, can you hear me?
Yep, I get you.
Yeah, I think there's a problem here. I think um some people are like in two classes at the same time, right?
Oh,
Like,
okay.
yeah, this is not gonna benefit you guys. Um, I think you should just drop one. You know, if you want to attend the Python course, you should just go there. If you want to attend this, you should just be here because it's not really beneficial to you. You should be logged into two,
Two
you
different
know,
ones. Yeah, sure.
demos. It's not doing you any favor. You could clearly hear that person. You can hear people talking in the background. There's a chorus going. This is the problem we have with the platform where when we have these demos, there's like conflict where we have somebody doing Python and then the other person doing Docker or something like that. Um, so if I were you, bro, I would drop one of these things. Because don't be rigid with your studies. You should either be on one side or the other. You should either be here or go with the Python. And then secondly, Patrick, I think we should go a little bit more deep dive into Docker because a lot of people don't understand this whole thing. And I
Hmm.
think for us to jump into Kubernetes, we should really understand Docker really well because some people
Right.
think we understand Docker and they just don't. They don't even understand why is it that you use Docker, first of all, right? What is the purpose of Docker? You know, like they don't. So we should go deep dive. And then also the kind that you just showed earlier,
Yep.
is a lot of people don't understand that's Kubernetes in Docker, right?
Exactly. Yep.
That's another fear of Kubernetes. So I I I think that yes, we should do this, but and like a lot of people don't have the background like we do. So we should take it really slow. I know you wanted to show these, but then we should also have that syllabus that we talked about because a lot of people don't see people watch YouTube video and then just assume they know something.
Right.
So it's good that we break it down such that it mimics a real life, a real work environment, which is what you are doing. It's just some people don't have the background like that, and then some people do. So it's fair that we meet halfway with everybody.
Yeah, and that's the tricky part is trying to balance that for those who are kind of experienced with it. So I kind of wanted to um though it's a it's an interesting scenario. So that's why I kind of asked in the beginning who knows what. And yeah, I don't want to go as far as diving. deep directly into Kubernetes. That's why I kind of like are having us do the Docker file and all that stuff. So they kind of get it. So, but yeah, but for those who are not really understanding the components of what Docker is, what it's doing, and the purpose of it, we can definitely take a step back there. But uh, for the sake of this, for the sake of I guess this like Flask application,
Yeah.
can we just like I guess we can just follow like you for those who know
Yeah, we could just
follow
move
along.
on. We could just move
Yeah,
along. Yeah,
and
yeah, we
then
could just go ahead, but
yeah, and then I'll go ahead as far as like do a deeper dive into it, so we can like do like straight containers and and
exactly.
then eventually get to the Kubernetes. But it's kind of one of those things where no matter where you start, it's still going to be people who may not necessarily know, and it's okay for those who don't know. You're already on the right track, joining sessions like this. So don't feel left out if you don't have any idea what's going on right now. You can still follow along, and go from there. So don't worry. But great point, Henderson.
No problem. Thank you, brother.
Hey, no problem, no problem. So we kind of went over the what a Docker file is and its use case. So what we want to do now is, and I got it, and I gave instructions. If you look at my actual GitHub, it actually gives you instructions on what you should be doing as well, so you can follow along again at your own pace. I tried to make it as straightforward as possible. So there is a prerequisite. You do need to have Docker installed on your machine, and you do want to have access to a Docker Hub account, because I want you guys to actually do this as if you are an actual, engineer and developer. So you would want to create a Docker Hub account if you haven't done that already. And we already pretty much gave you instructions how to access the Kubernetes cluster, which is not necessarily required right now. So the next thing that I want us to do, and you can download Docker quite easily. I believe that's in the kind install. I think I gave some instructions on how to do that here too. So if you're unsure, you can go here and do the, install Docker on your Mac and your computer and your Windows as well. So I gave you a couple of options to do that. But for this portion now, let's go ahead and go back to the README. And we're just going to go ahead and do the Docker build -t my Flask app, right? So what this means is, so Docker, certain CRIs, which is a container, a container runtime engine, it has ability to go and actually build and create images, that can run, as a Docker, as a container, right? So with Docker, it already has it built in. So if you do Docker build, and the -t means for tag. So this is essentially what we're naming our application. We're naming it My Flask App, and then the colon is just going to be like a version, right? So we're going to name this, so My Flask App v1 for the first version. And this dot right here is very important. You don't want to forget that. That dot essentially means um, look for the Docker file in this current directory. So let me copy that. And since we're in the directory here, since we're inside this directory and we do like an ls again, it's saying use this Docker file to create this image, right? So I don't know why I didn't copy, but let me go back. Copy this. And again, if you don't understand what's going on, it's okay. We'll get there, and just trust the process. Um, I might already have this built on mine, so it may run super fast. But again, it's saying Docker build my Flask app, and then name it version. So name it my Flask app version 1, and then we can just press enter. All right. And what happens is it went really fast because I already had a lot of this stuff cached already, as you see here, cached. I've created this image already, so it kind of pulled all the requirements. Yours may take a little bit longer because it's pretty much pulling everything from the web and everything, right? And as you see here, if it's done correctly, you should see where it says naming it docker.io library my Flask app v1. Somebody made a message. Is this meeting being recorded? Yes, it's being recorded. So yeah, you'll be able to access it. I'll make sure you guys have it in either group that you're in. So don't worry, I'll send it to both. So if you're gonna see a lot of images on mine because I have quite a bit of images, but if we see here, And I may just need to, oops, sorry. Where is it? Okay, my Flask app, right? So, well, no, I think I need, yeah, V1. Okay, right? So I created my app. It's called my Flask app. This is the image ID. It says created 3 days ago, but it wasn't. It just pretty much because it was cached. But it's a size of 163 megabytes, and as you see here, that V1 that we had is pretty much showing that tag. So essentially, like, okay, what does that mean? Okay, we have a image named my Flask app, but what does that mean? What can I do with this, right? So what we can do now that we have that image, we can run this command here to actually run that container. So let's go ahead and copy this here, and I'm going to go back to my terminal, and I can do this. So Docker run, right? For mine, I already have I have a process running on port 5000, but you don't have to do this. I just have to do it because I have a port conflict. So it's saying here, Docker run its image on port, the minus P means port. So run it on port 5001 locally on my side and within port 5000 within the container, because the container is it's pretty much its own, technically like its own like processor computer. That I don't know a better way to say it, but within port 5000 inside the container, I want it to show port 5001 here. So just saying, let's run its Docker image, so we can actually access it. This is the way that we're able to access it here locally, right? And then the minus E is for an environmental variable. And in this case, we have username, and username, if you remember in the Flask app, there was a username environmental variable, which defaulted to user if I didn't enter anything. But in this case, I'm going to actually change it to, let's just do payload pat, right? Then we're going to use the image that we created. Remember, so we were going to use a My Flask app colon version 1. So it knows which image to use when we create this, right? And we can go ahead and just run it. So now it's saying, okay, it created the application here, and the server is running now. So if I go to my local host and go to this port 5000, well, 5001, because I named it here, it's going to go ahead and show that. So let's go and actually go to the web browser and see this in action. So let's do localhost port 5001. All right, boom. Perfect. So as we see here, now we successfully created and are running our Flask application locally. And again, it's showing hello payload pat, which is the environmental variable that I pushed into when I ran the Docker run command. And it's saying welcome to K8's Kadence. And it's also telling us the version, which is version 1, as we expected, right? So that's the first Docker image maybe some of you have created, and it's simple as that. So what does that mean? So now that we have this locally and it's working, what Kubernetes can do is allow us to, not host this locally. Maybe we want to have like 5,000 of these, accessible to people. So if someone tries to, like, 1,000 people try to access this server, uh, there's going to be an issue because it won't be able to, serve that many people. So that's where we would have something like a load balancer and have multiple occurrences of this same exact container. So multiple people can access this and it won't crash anything. So that's kind of where we transition to the Kubernetes and stuff. And that handles the orchestration, and the back end stuff as far as load balancing, self healing, where something like this, like one of those containers or pods, what we'll learn later, go down, you'll be able to, easily recover from that, which is always important. You always want to make sure that your product is working. And if someone can access your website to make a purchase, that's lost money, which we want to, avoid as much as we can. So that's that. So if I go ahead and do and as you see here, it shows a 200, and that was just me accessing the actual server there. So that pretty much is the first Dockerized application. So hopefully you guys were able to successfully do it. And services as well. if you're trying to access this like from another pod or container within the cluster that you're in. But load balancer will pretty much make it available, or an ingress will make it available outside of the cluster itself. But services are all like local within the container itself, well, within the cluster. So that's pretty much that. So I'm not sure how far I want to go because we do have again quite a bit of a learning curve there. But what you would typically do is you're a developer and you've tested this locally and you made all your testing and it looks good. So you're gonna then want to log into your Docker Hub account if you haven't already, and you can log in and you can then tag your Docker file, your image, and then you can then push that same image into your Docker account, and then I can show you how it would look. I've already done this, but essentially is you can do Docker tag my Flask App v1, and then this is where you will put like your username. And in my case, my username is pvas24, and then it'll pretty much push it right to my Flask app. So I can have multiple versions of this. Say I upgrade something, I make some changes, I can upgrade and update my actual image. So as we're developing and continuously integrating and continuously, creating new things on your application, new features and updates, you're pushing that to the new image. So it's pretty much like saved as like an artifact. Yeah, that's right. Um, Perfect. Thanks for answering that, Brian. Um, but yeah, so I'll go on my Docker account. You can see how it would look if you once you log in and everything there. Let me log in to mine. And you can kind of see the images that I've done. So I named it, this one I did a couple days ago, and I named it here my Flask app. So now this actually is going to be inside here my Flask. So I have my three versions. And the good thing with Docker, you can set up vulnerability checks and scans. So it scans our image for any vulnerabilities. Looks like I have 3 high vulnerabilities and 2 mediums and 23 low vulnerability um, issues that I can go ahead and look at and improve and fix along the way. So it's a nice way to not only archive, which is this is your repository for your Docker applications, and this is a nice way that you can host it. And that's pretty much Docker Hub. It and it tells you how you can push things to your Docker Hub registry, and just make sure that you tag the name. But in my case, my name, my Docker login is pvas24, and yeah, you can have multiple different images that you post and upload as you build and develop your application. So that's there. I know this is kind of far-fetched, but I'm just gonna go for it anyway. Now that we actually have that Docker application, that Docker image available in our Docker app and locally, I can actually now use Kubernetes to actually host this as well. And we can go ahead and create, like a service, which someone asked before as well. And that service will be allow multiple pods and things like that to connect. So I know we haven't really talked about pods and what is a pod and what is a service and all that good stuff. But I kind of just wanted to go over the basics. And one thing I would always recommend is if you all are learning something, always, depend and lean on the documentation because it can explain it better than anyone can, to be quite honest, most of the time at least. And in a components and setup like this with Kubernetes, where there's so many moving parts, it's always good to depend on the container. So just to give you an example, what we have is something very similar to this image here. So for the visual folks, we have one control plane and we installed 2 worker nodes if you followed along with me. So we don't have this third one, but just in the case of our kind cluster, it's pretty much this is what we created with that command, right? And within the control plane, there's a few important components. There's the API server, and that is the pretty much the brains in the front end of the control plane. So it is this says it designed to scale horizontally, And that's pretty much when you do, like when you run a command, the kube API server is pretty much going to run that command for you. So if you do kget pods, or if you're looking for the services that you have, that is the way that it's, Kubernetes essentially is just a list of like APIs that you're calling at the end of the day. um and before we go there, I guess I can talk about what a node is, and I guess what pods are, right? So a node is essentially a it's compute. So it can be, a particular, in the case of like AWS, you have multiple different types of EC2 instances. For example, you may have a small T2 tiny, or you may have something that's specifically for like intensive GPU type of thing. You can have different types of nodes that are used for have certain like certain use cases. So those are what your nodes are. Pretty much the nodes are what the worker or what the pods and things are utilizing. So in this case, in my computer right now, my MacBook would be a node in this case, right? If But it's virtualized, obviously, because we have three nodes. But the backbone is saying, okay, the computer is using my computer to run, the control plane and the two nodes, as well as how I'm able to run my Flask app, as I was showing before. Um, and then we have something called etcd, which is a highly available key value store. And it's pretty much used for all the cluster data. So any running pods, anything that's that you have on your control plane, on your no, I'm sorry, on your cluster, this is what keeps a record of those things. The etcd is pretty much just saying, this is how many pods you have. And if you do like a backup or an update, the etcd server, if it's not in an etcd server, it doesn't exist essentially. What is the difference between a node versus an instance versus a server? There really isn't really any difference in those. A node is just what what you're using, like what the underlying, I guess, compute that you're using. An instance can also be an underlying compute, and a server is just a physical version of it. So these are all like flavors. I guess it kind of goes down. So from like a server, you can have an instance on a server, or instance is a server. An instance is a server, and then a node is also a server as well. It's just um I don't really know how to explain that, but they're all essentially the same thing. There's no difference in between those three. A node can be an instance or a server. Yeah, essentially it's a server, um, just labeled something differently. Perfect. Um, but now as far as exactly, and these are other things that we can talk about, like kubelet and all that stuff. But before we even get there, I guess let me see as far as what it says, what a pod is and stuff. So a pod is it's the smallest, like how do they say it? It's a basic building block for Kubernetes, and it's the smallest unit in the Kubernetes object model that you can create or deploy, and it represents processes running on your cluster. So you have let me go back to the picture. So within a node, you have pods. These within a pod, you can have containers. And a container itself is, again, what we just showed you. It's running a process or something like that. However, a pod can have multiple containers. So you can have one pod that has 3 containers, 4 containers, 5 containers, but in a pod has to have at least one container inside it, right? For it to run, not for it to run, but you need to have a container has to be within a pod. And again, you can have multiple containers in a pod. And within that pod, a pod has to be within a node. And within a node, multiple nodes together make up a cluster. So if that makes sense. So you have the cluster. I don't know what they call it, the Chinese doll, where you have something, you have the small doll in the middle. The small doll is going to be a container. And then within, outside of that is going to be the node, the pod. And within the pod, outside of the pod, there's going to be a node that, multiple pods can run in nodes. And then more than one node is equivalent to a cluster. You need to have multiple nodes, um, and multiple nodes talking together is what makes the cluster overall. So just remember, pod is the smallest deployable unit. And within the pod, you can have multiple one or more containers. And within that pod, outside of the pods are actually hosted on the node, which is the compute, which is going to be an EC2 instance, which can be a server, or a an instance or server, as you were discussing before. And at the end of the day, it's just allowing you to run a process or an application in most cases, um, and gives you the ability to go ahead and orchestrate that whole procedure. How can if we have different types of nodes, for example, say we have a basic EC2 node that's just used for general purpose, or we have a specialized type of node that's like a high GPU intensive, it's running, you're running like machine learning or something like that. You can have certain workloads on those particular types of nodes. So that's where the node makes a difference as far as the type of server and the type of CPU and type of resources that you have, to be able to run certain things. So that's that. Again, Kubernetes is not something you're going to learn overnight, and I'm probably doing a terrible job at explaining these components. But the more you practice, and the more access you get, to experimenting, especially when you have a cluster locally on your computer, you'll be pretty much in great shape. Because right now I can do. Do I have any pods running right now? Got one pod named pod. Okay, let me see. Right. Okay. Nothing else. So Kubernetes is pretty much going to allow us to do almost the same, pretty much the same thing that we did with Docker when we did the Docker run. We can do the same thing here with Kubernetes, right? So I'll just show you as an example how that looks. So when Xing, you can ask your question.
Okay, cool. It is related to this, but I just want to just confirm. So how often do you recommend actually practicing on Kubernetes, especially for beginners that haven't necessarily created their cluster or built the Docker images yet? They can use samples, but
Mm-hmm.
more so just used to the commands and the features and things of that nature.
Not to be discouraging. You don't necessarily need to know like a whole lot as far as with Docker, but you need to learn Docker. It's like learning. It's like someone trying. It's probably a bad analogy, but it's like someone trying to learn Portuguese.
When you don't know Spanish,
Yeah, you
yeah,
know what I'm
no,
saying?
yeah, it's
Kind
the
of like
basis.
that.
It's the basis of it. Yeah, I get you.
Yeah, and I don't think Portuguese and Spanish is a really good example because it's probably terrible for those. But
Yeah, I got you.
but just for the sake of like an understanding, like a quick reference, it's kind of like that. So you do want to know the bare bones, and it looks like Idris shared a cheat sheet, which is awesome. But even before we get to cheat sheets, we do want to understand like simple
There we
Docker,
go.
Docker
Definitely.
run, Docker, how I can do Docker PS. How many Docker, what's running? What's running right now? What do I have running? You
Mhm.
know, and I have quite a bit things running because I have a node. I have
Kind.
my node running and
Yeah.
kind running in the background, which is just again, it's kind, Kubernetes in Docker, as
Mhm.
Anderson mentioned. But yeah, but don't be discouraged because you don't know too much Docker, you don't know Kubernetes. You can learn them, kind of at the same time. But again, you do want to get the basics of what Docker is doing, because when you realize it, Docker is just an orchestrator. So it's doing the same things what Docker's doing, just at like a production level, and you can, manage maybe 5,500, 1,500 different nodes or
Right.
containers, and things like that. But great question. Don't be discouraged. Try an experiment. Make your own image. Experiment. Do what I was doing as far as like when I did the Docker run.
Mhm.
change it to something different, and go from there and really see the power of, hey, I made my first Flask application. All right, now I made it. Okay, now how can I put this on Kubernetes, and how can I expose it so someone like you can go ahead, or me, you send me a link, I click it, and it actually redirects me to that container that's running just like this. It's literally no different. Um,
Okay. So
so it's just
maybe,
locally.
maybe this is the same question but different. So what do you recommend in practicing Docker? I have experience using Docker just on my own, but for people that
Yeah.
don't, what's the recommendation of, like, besides Docker run, Docker PS, to creating the Docker file? Is that like pretty much the standard of what you need to know in order for you to be able to proceed with using Kubernetes, or do you recommend more like the networking part of Docker, things of that nature?
Um, I wouldn't say go into like you need to know this. You need to know it, right? But even me right now, I cannot tell you for everything about Docker and how it communicates locally, with your machine. It's a lot of intricate things when it comes
Right.
to that. So learning Linux, and that's another thing to bring up. Learning Docker is not the only thing that you ultimately need to learn, because if we go into like IP tables and things like that, that's what runs the networking stuff behind it. It's creating a virtual bridge, and it's a lot of different things. But I don't want people to get too overwhelmed with that, because they could kind of get away with it in the beginning. And again, I don't want people to be like discouraged, like I would never learn this stuff, because it can be overwhelming. Absolutely, it is overwhelming. But the basic thing I would recommend someone do is, like we did before, is creating their own Docker image. Maybe creating another type of application. Maybe you already are working on an application that you have, and try to Dockerize it. Try to containerize it. See if you can get it in a Docker image. Get all the dependencies that you need for your application to run, and run it. Create it. Build. So the best way to do it is build something, and that's kind of why I wanted to bring this up, because I can't educate you on Docker in 30 minutes, and it's not expected to know in 30 minutes, but kind of gets you like, hey, this is what he did, this is kind of what I can do. I have all the files that I need to create my Docker file, and I can go and actually push this into my own uh Docker repo on my registry. And you are able to go ahead and, like, experiment and get that portion done. Once you do that, you can understand the intricacies of Docker networking, and all the other complex stuff that even people who are running Kubernetes right now may not be able to tell you how um, IP tables work, and how a firewall, and how these things are communicating. It's a lot of very, very intricate details to learn. But just learn from the beginning. Start creating Docker run, Docker build something, and push it to your registry and run it. Make sure it actually works. Create your own Flask app. Use that Flask app that I use. Create more environmental variables in there. There's a lot of different things that you can do with this within the scope of what I already kind of created for you. But again, don't be limited to what I'm suggesting. Search up, like, on YouTube. There's always good resources there. They have like actual, like, hour and a half long videos of helpful things that you can do. But this is just like a getting started, quick and dirty way to see what Docker is, what it's doing, and how it can actually be, how is it related to Kubernetes and stuff. So it's going to be some prerequisites, so for sure.
Okay.
Anderson, yeah. Hopefully
Yeah.
that
So,
answers the
oh,
question.
yeah, yeah. Can you hear
Yeah,
me?
yeah, we hear you.
Yeah, I just wanted to add to what you said earlier and explained it very well. I just wanted to add to the person who had asked the question earlier. So
Hmm.
the take home is that the main purpose of Docker, right, is to build, run, and ship application, right? So the idea, like you saw how Patrick, he kind of coupled all the dependencies that the application need, and then he built the image from that, right? And now that image we can ship it to like a Docker hub so that other people could use it, right, to run it, right? And then now the idea is that if you have multiple containers, let's say you have 1,000 containers, right? How do you manage this container, right? because they'll be everywhere. It will be hard to know which container belongs where. How can you find it? What is the purpose of that container? What version of that container are we dealing with, like you were showing earlier? Now, the solution to that is Kubernetes, right?
Right.
So Kubernetes basically manages those containers and it puts them into pods so that you
Mhm.
can now create namespaces and then make sure you understand that, all right, this Python app, Flask API or app, it belongs to this pod. Now, let's
Right.
say we're dealing with Nginx, it belongs to that pod. If we're dealing with JavaScript, some React app, it belongs to another pod, right? So now you know exactly where things are located, right? And that's what
Mhm.
Kubernetes is helping us do is to manage where all these Docker containers are located, right? Now, once we have that, and it just helps us to make sure that we know exactly where everything's are. And the beauty of this is microservices, right? Like in the past, people had monolithic application. Monolithic simply means that you have this one code-based application where if you had to do or make any change to that application, you have to bring the whole thing down, right? Well, one of the benefits of containers is that you can build what they call microservices. A microservice basically means that you have multiple different services of your application that's bunched up together, right? And so if you put them in separate containers, like for example, you could put your card, right?
Yeah.
A container that only deals with stuff issues that's related to check-in, PayPal, right? So if
Login.
let's say if you bring one of them down, it doesn't impact your application. Does that make sense? And you can bring it back up. If you bring one of those servers down, it doesn't impact the site. Like the customer will not feel that something is missing, right? So
Exactly.
you would still allow customers to be able to have access to what you are selling or what you are doing with that application, right? Without them
Right.
noticing that something is missing. Now, when you fix that thing that's missing and you bring it back up, then they won't even feel it, but they'll see that, oh, there's a new feature. So a
Mhm.
container is helping in the background to make all these things happen. And then the Kubernetes cluster helps to manage all those containers. That way they don't get missing. You know exactly where things are.
Right.
That's the take home in summary of what we're trying to achieve.
Perfect.
Yeah.
Perfectly stated. And just to reiterate what and reinforce what Anderson was saying, which was exactly what it was, what's doing and the problem that it's solving. Um, Containers are uh, they're they're immutable, right? So if there's any change that you need to make on an actual container, it's not something simple that you can just go in there like a virtual machine, update the code, make some changes, change the application in there, and then save it, and then it is automatically going to take the new updates. These containers have to be shut down, completely, stopped, and destroyed, and then a new container is built and created. So if you're making a new version, it needs to recreate itself, and with having the new code pretty much inside it. And that kind of also what helps with Kubernetes, where you're able to do this at a not only a rapid pace, but as an orchestration where it's multiple pods, or containers, that you can quickly spin up, spin down. You can set up auto scaling. So those are the components. It's like the abilities. You have the reliability factors in there. You also have, like, for example, uh, the ability to auto scale. It's a lot of the non-functional features that Kubernetes provides, for a business and a business critical application. So you won't notice the card is down, and again, it won't impact every single person. Instagram, you may not be able to post a picture, but you can still go down the scroll in the feed and you're still able to like a picture, for example. But you may not be able to post a picture for a minute, if that makes sense.
Yeah, it makes
That
perfect
makes
sense. I do know Kubernetes has something to where you can deploy, do rolling updates, so where it be minimal downtime for that. So yeah, yeah. What you guys said made purpose.
Awesome, awesome. Thanks, Anderson, on that as well. It looks like Soho raised they have a question.
Yeah, thank you. Thank you for your help and thank you for all the information that you share with us. I
Perfect.
have a question regarding, sorry, by the way, I have a question regarding the creation of the clusters
Hmm.
that you give in your GitHub.
Yeah.
And I didn't really understand the configuration file. I know, I mean, what I'm reading that I think is probably Kubernetes call this API and build that, but I'm not sure regarding the the other two components that are there. So could you explain a little bit, please?
So
Or if you have any documentation?
yeah, yeah. So I don't think I really understood the question.
Oh
Can
yeah,
you ask again? I'm so sorry. Yeah. Can you ask
I
again?
was talking about the kind cluster that you mentioned before that we need to
Hmm.
start. So you were talking about like yeah the configuration file, the kind config. Yeah.
Yeah. Hmm.
Are you?
So yeah.
I'm sorry. I'm sorry. So I just want to make sure you answer the question. Are you talking about the kind cluster config file in order for him to create the cluster in the first place?
Yeah, I did create a
Okay.
cluster, but I don't understand really the roles, you know.
Oh,
Oh,
I see.
The
okay.
role
Yeah.
that you have there.
Great question. Yeah, yeah, yeah. So I'll be able to answer that. So Kubernetes has essentially like two types of roles really. There's a
Hmm.
control plane node and then there's the worker nodes. So remember we were just discussing with Anderson about if there is something where we orchestrate and we create a certain amount of 1,000 of these pods. The control plane manages like all that type of stuff. So it manages the scheduling. Okay, we have multiple pods. What node are they going to be on? The control plane pretty much is the brains of the operation, and the worker nodes are the workers. So this is where your workload is actually going to be on. You don't really want to put anything on your control plane because the control plane, you want to make that as lightweight, and you don't want to have any production workloads on that. And in fact, you in a real world production, you would prefer to have three control planes, 3 to 5 control planes, because you want to have that redundancy. Because if one of those goes down, you're still able to communicate with your cluster. So control plane is like the glue to everything. And then the worker nodes are just workers. They just host the applications or the service, or in this case, the pods that you have. And if you do if you do K get nodes, you can see them as well. And it says here it has a specific role, and this role is the control plane. And the control plane has all those components. So if I do k get pods minus n cube system, these are all pretty much on the control plane. So you have like certain, like, remember I was discussing the etcd file, which is the key value store. And then we have like the cube scheduler. The cube scheduler is going to say, all right, this is going to, I'm creating a k run pod. I'm creating a pod. Where is it going to be working on? Is it going to go on worker or worker two? This is what uses to determine that. And then you have things like the controller manager, which pretty much is, for example, hey, I need to make sure that I have 5 of these replicas, or something like that. Um, so this is pretty much the brains of behind everything. And then a worker knows they usually just have the workload on there. But those are the two differences, and they're all obviously important. But this one is kind of um, the lion in the jungle.
And so it looks like that the control plane is another word was another way to say master. Is that correct?
Yeah, not an acceptable term anymore with where we're at now. But yeah,
Which
it's
one? So the
primary.
master is not an acceptable term anymore. It's control plane.
Yeah, where I work at, they don't like that. So yeah, it's no longer what they call it. But yes, exactly what it is. It's the primary. Um,
Primary.
it's the primary, right? But again,
Okay.
no
Oh,
workloads you should be put on there. And then once we go in the future, we'll show you why when you do, like, for example, creating a pod. So if I could do k run, I'll just create a pod randomly now. K
mhm.
run test, and then I can do dash dash image equals engine X, and that's it, right? If I do that, let's do k git pods. You can see that it's being created. And okay, it's created now, right? And if I do a k git pods dash w, no, dash oy,
Right.
that's going to show me that, okay, this test pod was placed on my cluster worker too. So it was able to go ahead and get loaded and it's running on that cluster. So right now, only pods that are going to be anything scheduled on is going to be my worker and my worker two. So hopefully that explains
Yeah,
that. But
yeah,
yeah,
thank you. So if I would like to add more nodes on
yeah.
my cluster here, do I need
Mhm.
to follow the same process like role and then worker three?
Yeah,
Eh,
in fact, if you so you know we have the let me do ls. So if I do kind vi kind config, if I do
mhm,
for example, I do a paste, I can have this much, you know. So
mhm,
it's up to you how much you want. But yeah, once you save it and then you go ahead and do the kind like create the cluster
mhm,
dash name and you reference this YAML file, it's
mhm.
going to create based on what you put in there. So it's up to you. I just was trying to be conservative because I know you don't need necessarily that much, but if for your use case, you can definitely do that for sure. So
So do you have
And
a
this was
documentation
on the
for
video.
that?
Oh, I'm sorry. Go ahead.
yeah,
Do
I
you have
have
a
a video on that and
yeah.
I explain that
Mhm.
too.
Thank you.
Yeah, yeah, great question. Um, Someone said K. Oh, sorry. Yeah, I kind of skipped over that. And thank you, Desiree, for mentioning that. So yeah, a tip for that I would recommend is you can set up aliases. And this case, I have where is it? K here, kubectl. So mine is going to be so K is it's kubectl, but to shorten it, I just use K, which for an alias for kind. And I can just do like K and then or kubectl. It's literally the same thing. So great thing to have set up. And in the GitHub, I also mentioned you can do that as well. It'll show you how to set that up too. But yeah, great question. And before we go continue on, I wanted to go ahead and just show you guys how we can set this up on Kubernetes and how it looks. So if you haven't created a YAML file before, I'll show you two ways on how to do it. There's an imperative command and then there's a declarative command. Imperative is great for the exam. Real world, it's better to have it imperative declaratively. And the two differences in imperative is pretty much doing it from the command line. So we can do a cube, CTL, run, a pod and all that good stuff. Declaratively is when we actually open up a YAML file and like we create, the file because there's this thing called GitOps and that's a whole nother topic, but that's the way that you want to do, especially if you're going to be learning Kubernetes, you're going to want to know how to, um, create, manifest files and being able to have versioning and stuff like that associated with it.
Well, quick question. So you said which one is the preferred? It's declarative. That's the preferred in in the
Um,
main in the production.
in production, yeah, because they have these things, for example, like for, like my GitHub, right? So you can
Yeah.
have it to where you have you have a pipeline going on. So you just update your manifest file. So I can do for example, I just do it here. So okay, run um I just name it laugh. That's the name of the image. So kubectl run this um pod named laugh, and then I need an image. So I'm going to reference the image equals nginx, and then I can do so I can, and I press enter, right, and I create like before, or I can do a dash dash dry run equals client. I can spell minus output YAML, right? So what this is doing is this is creating a file for me already. And this is what you would put inside like your GitHub account. And once you update this in your GitHub account, you will have something, polling that and it will automatically run a pipeline. So it will actually go into Kubernetes, see that there's a change in here, and that's when it will actually update. But that's just real world in the test environment that we're worrying about. Just worry about that you can do it two ways. And again, uh, you can like go into documentation and like pull an example like this, but you can do it right from the command line with the dry run equals client option. And this is a great way that you can not only make less mistakes, but it's just much quicker than having to go and search in the documentation, which you can use in the exam. You can use the official Kubernetes documentation while you're taking your test, for references. So that's one great tip as well if you weren't aware of that. But this is imperative, and if you were to create it, like say if I went and did like this, so I'll show you if I do this copy here, or just do this. I can redirect this into a file called laugh.yaml, and then I can do a k create minus f, which so I'm kubectl create this resource which uses this file. The minus f flag is just referencing a file, and I'm just going to reference that. And then now, as you see here, that pod named laugh has been created. And if I do k get pods, you would see that that laugh pod is in there. So that way you can create it. Or if I can do a k delete, right? A delete minus f, and then I can do laugh, deleted, and I can just go back here, and instead of doing the dry run, I can just do this, and it will do the same exact thing, right? So okay, get pods. So that's the difference between declarative and imperative. Imperative is just the quicker way. If you can do a command, if you can create a particular resource with the command line, I will always recommend you doing it in a test environment. In a real world environment, you're not necessarily going in your control plane on your cluster and creating any pod. You shouldn't really be creating any individual pod, to be quite honest, in the real world. So, but that's just a whole nother discussion that we can have. But I guess, does anyone else have any questions before I move on? I'm sure you guys probably have quite a bit, but I want
Yeah,
to show
so
you guys how to.
what do you do in the real world? Do you just edit the YAML files?
No, no, no. You would have something where you have version control, which is like using Argo CD and having like your GitHub account. And like you may have a production GitHub account where you push your code. So you would push that configuration file that we created, that laugh.yaml. We will put that
Mm-hmm.
in a GitHub account. And then what will happen is it will trigger a build, or it will trigger a pipeline. And that pipeline will then go ahead and say, Argo CD, there's something called, and I'll probably do a video because I actually created I contributed to a what do you call it, a workshop, for AWS, and it goes over GitOps as well as using Argo CD. And Argo CD pretty much is looking at your GitHub account, and if it notices that there's a file that's been added, and then it sees that there's a YAML file, it's automatically going to go ahead and apply that. So it's going to do the it's going to do the kubectl create for you. So it automatically will change it. So if you ever need to revert back to something, you can just do it in either your version control. So you can just delete that file in GitHub. Argo CD is going to see that file is gone. It's going to delete that pod or that service or whatever that resource is. So you have control of things not going all over the place, because you need a one central source of truth, because without that, if you're going inside making changes, no one knows what the change was. They can't undo it. It can get very ugly that way. So having the version control, or GitOps, that's what it's called. Git, using Git for GitHub and operations, that's how you're pushing new code into your clusters. So that's the way to do it. So in the real world, you wouldn't probably even access, you wouldn't really do this at all. I hope so. That would be a very bad practice. That would be an anti-pattern.
Yeah, I have a quick
Thanks.
question regarding that. So
Yeah.
in real world, right? So where the image are pulled and where all the variable are stored.
I'm sorry. Say that again.
In real world,
Mm-hmm.
where image are pulled and where also the variable are stored. For example, the sensible variable.
The sensitive variable. Well, there's components. There's something called secrets that we can talk about at another time. But there is something that we have as our secrets, and you can connect that to GitHub secrets. I believe they have one, as well as like what is it? Terraform HashiCorp secrets, or HashiCorp Vault. They have some secret management that you can use. AWS secrets you can integrate with Kubernetes. There's different ways that you can still have like variables but still be secure. Secrets in Kubernetes is kind of a joke. It's just, base 64 encoded. So if you have a secret, it's not really secret. It's just not in plain text. But those are ways that you can do. But for example, like we're doing environmental variables, you had a great question. What I'm going to do, and we won't be able to have time to do it today, but the next segment is when we're, using the environmental variables inside Kubernetes. We can use this thing called config maps, where you can upload configuration files. In this case, we can upload a file that already has those variables like my username and all that other stuff in there. And that's where you would be able to manage once that container is installed. All those environmental variables will be pushed into there. So it's not necessarily having to be in the image by default, because it's a variable. You may want to change up the name, welcome someone else. And I'll also show you, for example, in this application that I created, that we're going to be using with the Flask app, I have a variable for the background color as well as the font text color. So that's kind of a fun way that you can experiment with that. And kind of that's where I was going to, lead into with the once it's actually on Kubernetes. But great question. Did I answer it? Hopefully I did.
Yes, but you forget the images.
Oh, there are images. How do you get the images? Well, the images, there's Kubernetes has a I forgot the name of the where they pull their images from. Someone may have it here, but
Docker Hub. I think it's much
Docker
in
Hub,
Docker
and
Hub.
there's artifact.io, I think it's called.
Yeah,
I think.
Cryo. There's
Go
Red
ahead.
Hat has another one called Quay.io.
Oh,
And
Like
is
okay.
there
Red.
a way to where I think I read it? So is there a way to where you can actually configure where you can get your repository, your containing repository? Like if you have like a local one,
Yeah.
you can actually configure it to where it comes from the local one instead of Docker or the other
You
repository
can
automatically.
Yeah, you can have it to where it pulls locally. You can have it to where it always pulls from like your GitHub account, or you can have it to where it only looks locally, so it only is looking for, you know, an image that you have that's on a particular like repository. You may have a private repo that you want it to pull from. So yeah, you can configure it to where it's pulling from that. But typically, if it's just doing like a Docker, like if you're doing a kubectl run, like image, it's automatically going to pull from like the Docker Hub, the official like webs, the official image that is being maintained by them, or if it's open source by the open source crew. But yeah, it's pretty much going to be pulled just like we do with Docker. Remember, Docker and Kubernetes, there's nothing much different about them really. In that case, hopefully
Hmm.
that answers it for you. But yeah, you can control, because again, someone has like some type of bad container that has like a whole bunch of like vulnerabilities, or it's something where it can like expose your token, your Kubernetes token and your API token and stuff, which can be bad. You don't really want to just pull any image from anywhere, so you can control where it actually uses where it pulls the image from.
Thank you so much. You're the man.
Of course, of course. Great. Anderson, you had a oh yeah, he lowered his hand. I think we have
No,
two
I
other.
still have my hand up. I was gonna say, I think it also depends, right? Because let's say, if you have a public image, it will be pulled from a public registry, right? And if
Mhm.
you are at work where you are not pulling containers from public registry, you probably do like to ECR. It will be a private registry that you will be pulling those images from, right? And most of those images are also stored in like artifactory, because artifactory sometimes comes with like a registry, and then of course if you are doing some tests, you can do that locally. But by default, Kubernetes is going to pull from a public, any available public registry, I think.
There you go. There you go. And yeah, you can create, and you can pull again, like you said, from a private registry. So that won't be a problem. It's just gonna have to get authenticated, which it shows you how you can pretty much do that here and authenticate. So let me show you actually how to do that, right? So now that we have our application locally, let's go ahead and do this. Let me go ahead and open up the deployment, and I'm gonna go ahead and CD to version 2, right? I'm gonna CD to Flask App version 2, and I want to show you guys something, right? So let me ls. So I'm gonna just do a quick Docker build. Let me go back to the instructions so you guys can also see what we're doing. So I'm gonna go back. I'm gonna go to Flask App v2, and it's the same process. We're gonna build the image, right? So I'm in this repo. I'm in the Flask App v2 repo, and I'm gonna build my image here, right? So Docker build -t my Flask app, and I'm just gonna name it version 2, and then I'm gonna put a dot, so it's pulling directly. It's using this Docker file, right, to create this image and following the instructions that I specifically gave it. So I'm gonna do that now, and then I'm going to show you how we can do this. So now it's created, right? In fact, I can do a Docker run. Let me do a run. Oh, and do a yeah, Docker run. Right. So in this case, we have multiple variables that I can use now. So I'm going to use my Flask app. Instead of version 1, I'm going to use a new version that I did that we just built, right? And then there's other environmental variables that I have now here. So I can also update the background color and the font color. So let's do this here. Let's do BG color. I'll just copy all of this right here. Right. So I got the username already, right? And the color. So anybody give me a specific color that they want to see as far as the background? What color should we try?
Maroon.
Oh, no,
Might be too
maroon.
dark though. I like maroon though.
I don't know if that color is gonna populate. It may.
It's
I mean, not.
no, you probably have to do the code. I say green just to simplify it.
Green? Yeah, let's do green. Okay, let's do green, and then font color. Let's keep it white so it's clear, right? And then the username. I'm gonna pick on Anderson, right? And perfect. So now I'm running this Docker image, and I'm using my port 5001, and let's do it, right? So now it's running there. Remember how it looked before? It was like blue and like white lettering, and it said my name. So let's go ahead and see what it looks like now. So if I can do localhost 5001, you see there? Now it's green. And it says it's running on pod, whatever, right? But I'll show you guys what it looks like later. So remember how this looks. So you see here, hello, Anderson, welcome to your K8's Cadence app. So actually it's pulling in information that we're putting in there, and it also updated to version 2, as we see, right? So I do that to say this. Let's go ahead and actually check out this deployment file. So let's go ahead and cat this open. So cat deployment.yaml. So we haven't done this yet, right? But I pushed, as I showed you with Docker, I pushed this image with the Docker push command. I pushed that to my repo that I have access to, right? And it's public, so anybody can literally access this if you even try it right now. So let's break it down. The API version, apps v1, guys cannot, this is not necessarily like super important, but the kind, what is this resource creating? It's creating a deployment. And then the metadata, what is the name of my deployment? So my deployment is going to be called my Flask app deployment. And then we have this thing called spec, which is Stanford like specs. And I want to have 2 replicas. So I want to have 2 two copies of this. And then selector match labels. You'll learn about labels and things later. That's probably the most important thing in Kubernetes is labels. But the application is going to be labeled as app my Flask app and my Flask app, right? So this is the important spec here, which is saying, okay, the name of my container is going to be called my Flask app. And what image are we using? I'm pulling from pvas 24 and then / my Flask app v2. So I'm looking for this application, run this image, and then it's going to be on port 5000. And as I mentioned before, we have those environmental variables. We have the default username there, background color, light blue, font color, right? So I can go in here And if I want to edit that, I can edit it here and change the color to something else, right? So let's go ahead and let me actually VI and edit it here. So edit the deployment to have a different name. Okay, I'm going to pick on Desiree. Okay, so let me save that. Right. So now if I do a K create minus F deployment, I'm going to create that. Now if I do K get deploy, so kubectl get my deployment that I just created, right? And what does it say? So this is how we break this down. So the name of that deployment was named, let's go up here, was named my Flask app deployment, right? So that matches. And it says ready. What does that mean? It's saying that the pod itself is saying that it's ready and there's like no issues going on. It looks like it's running fine. And it says 2 out of 2. It's saying 2 out of 2 is because we have 2 of these running, right? So it needs to make sure that both of these are running, which means that both pods are running and working and they're up to date. Both of them are up to date and they are actually available right now. And the age is saying how old is this been created. So if I do do it again, it'll show a greater age, right? As far as how long it's been created. So, okay, now what? What does that mean? So with kind, as I know, Brent was mentioned about the networking and stuff, it can get very interesting. Kind exposes like their ports on like port 30,000. So what I have to do here is let me see. Let me go ahead and show you this so how we can actually see this application, right? Or I can just curl it if I want. Um, so let me do this. So now remember we did it on port 5,000. So
Oh, quick question. I know you explained, but quick question. Are you on Mac? Are you doing it on a Docker? I forgot what it's called. For the containers.
my
The,
runtime.
doc- the Docker desktop, or does MacBooks or Mac actually have it to where like Linux, you can actually run it the Docker? Because I know in Windows they have to technically run a virtual machine, a mini virtual machine for them to run Docker on Linux. But I wasn't sure about doing it on a Mac.
I'm using Docker desktop here. So
Oh, you are
I'm
using Docker desktop.
yeah,
Okay.
I'm using Docker
Okay.
desktop. So yeah, that pretty much been it's been working for me. But yeah, great question. So now we have this other thing called a service. So now how a service pretty much is going to expose my application, right? So now that I have it created and okay, my bad. So let me do a cat my Flask app, right? So how am I able to see this port, right? How can I access this from Kubernetes? In this case, since we're running this locally, it's a little bit different. So
Mm.
I'll break this down as best as I can. So there's a service, and the service is a type of like load balancer, right? And services pretty much expose applications, right? So in our case, we have those 2 pods, and I don't know if you recall, but it was a label selector. It's saying select anything that has this key and value at my Flask app. If it matches, I need you to expose that port. So whenever someone exposes this, they're able to access those 2 pods that we mentioned. So they can access each other interchangeably. And I'll show you whether with refreshes and stuff like that on the page, and you can see it switch between the two nodes that we created. So in this case, we have something called a node port, and there's different types of accesses, but we'll just focus on node port right now, right? So there's a cluster IP, which is pretty much local to the cluster itself. Node port is saying on the say this was like a public server. Say the IP address was 10.10.10.10. I know that's not a public, whatever, but just an example. Um, if I added the port 3000 to that, I'll be able to access it directly from that cluster itself. And I'll be able to access it. But that's not a really, great way because you can have like port conflicts and all that stuff. But in this case, we're just using a node port 30,000. Just remember that. And node 1000 and it's exposing port 80 on the container itself, and it's using the TCP protocol. And is using port 5000 for the container. So sorry, this is the container port. So within the container, it's exposing 5000 like we did before. We exposed 5000. Remember, I reverted it to 5001 for my computer, but 5000 is what it's exposing on the container within within that pod. And port 80 is just, from the pod itself is using port 80, and the node port is 33,000. If that doesn't make sense now, it's okay. It will in the future. But essentially, let's go and actually create this, right? So let's do a K create minus F my Flask app service. And the service is being created. So to do a test to see what happens, so let's do a K get SVC or service. And I'm also going to do a /EP, which is endpoint. So Kubernetes always has a service. These are how all the pods are able to communicate with one another. That's by default. All pods are able to communicate by default, within a cluster. And that's because of this service. Next thing here is the one that we created, which is the My Flask App service, which is using the type node port. So this is accessible outside of the cluster, as long as I have the IP address of this, right? Of the node. And then the cluster IP is given, and then it's saying, okay, to access me, you need to go ahead and go through port 3000, right? And if we see down here, there's two nodes, there's two endpoints, and these are those pods. So if I do a K get pods minus OY, we can see those IP addresses should match. Actually, let me do dash label I think it was like my Flask app or something to make this look better. Copy, right? Let me paste that. So look, there's no, oh, oops. Whatever. I don't know why it's not showing a label. Okay, well, that's the actual labels. And you can see those two apps that we're running, right? So they have that label app, my Flask app, right? Oh, I didn't put an equal sign. That's probably why. Right, so those two. And so my Flask app, it's a deployment, and then it's the pods, the deployment ID, and then the pod ID for each one. So as we see here, these IP addresses 10.244.2.4 and 10.244.1.4, it's going to show that here, as you see, 1.4 and 2.4, and it was able to select those two pods because the labels match them together. So that's why that service is going to expose that service. So to access that, let me go and clear that up here. Let's go ahead and do this. Someone asked a question. They said their pods are failing. Cisco container name exec. Container name my Flask app is a format error. Format error. Pods. Your pods failing. Cisco raised his hand. Okay. Not sure what happened. Yeah. You can unmute. You can ask your question. I'm not really sure why it's showing up. Okay. User bin Python exec format error. I guess he's not. You can talk to Cisco if you want.
Can you hear me?
Yeah, we can hear you.
Okay, yeah, I run pretty much the same deployment YAML file that you run. So I
Yeah.
use your image, but I'm
Mhm.
running through GCP or GKE Google environment. So I'm having a crash loop back. It's been looping back like for five times already, crashing. So I have 0 out of 2 container available. So 0 out of 2 pod available.
Okay. Are you able to make like run your own image and run it locally from there?
Yeah, I run it through the
It
same
ran.
Google Cloud. It run pretty well.
It
So I have
ran,
it.
but
Yeah,
the deployment. Okay. And which
but
deployment file are you using? Are you using version 1, 2, or 3?
version two,
Version
version
2?
two. Yeah.
I don't know why it's.
That's what I clone, but we can look into that after
Yeah,
this
yeah.
one.
Let's look into it after because I want those to see how
Okay.
it should look. But I thank you for following along the whole time.
Yeah.
That's pretty sweet. But so the interesting thing with Kind, uh, their local host, so that port 30,000, and I don't want to nerd you guys out, but no port can only have ports from 30,000 up to 32,667, right? Um, and those are the ports available for the node port. In this case, because we're using like Kind, if there's some type of conflict, so I can't do like a port 30,000, it won't find it. But what I did was port 3000 locally here is what works for me. Should service on, let me see. Okay, get pods. Deployment's running. Services created. Let's see, service. Um, Earl. Let's see what this should just be. It's not finding it. I don't know why it's not. It's running here. Okay, I don't have anything conflicting with it right now, but it should have ran local host. Five thousand. Not sure why it's not.
Now, is it 33,000 or 30,000? If it was 30,000.
It's 30,000. But with Kind, they have this like weird setup where it has to go through. It's like port forwarded to 3000. Um, but I don't know why it's not working now. We'll have to go back to. Let me try version one maybe. I haven't tried this in a while. It should have worked though. Let's try version three. I'm gonna try version three. So I'm gonna delete the service and the pod. I'm gonna delete the pod. Hey, delete pod. I mean, deployment and it's in my Flask app and deleted. And then I'm gonna go in CD to Flask app. V3. And then I'm going to create. I already have it posted on my GitHub, so my Docker account. So I already have version three, so I don't have to do the Docker build or anything like that for this sake. Oh, it's not working now. I think it's something related to my Kind cluster because I recreated my Kind cluster. But what we could do in this case is I can k-exec into a pod. So let me do it ls. Okay, get pods. So let's go ahead and go into this that lav pod that we were in, right? So there's another way that you can actually get into the actual running pod. So if I do k-exec mine is IT, which is the interactive mode, give me a TTY, and I can do the name of the pod, and then I can do a command, right? So the dash dash means run this command. So I'm just gonna run a simple shell command. And now I'm actually inside the lav command. So if I do like host name or something like that, it should work. It should be named lav, right? So I'm inside the actual pod there, which is cool. And then what I need to do is let me do a curl. So curl, and then I can curl the name of the service. So we name that service here. No, where is it? My Flask app. So let me see if I'm able to curl this. All right, so there it's right there. I don't know why it's not showing up now for some reason. I don't know, but I know it's related to kind and the kind settings, and I recreated my cluster, so it probably is probably need to enable some type of port forwarding on it for port 3000. But that's that. But as we see here, if I curl from within the actual pod, it says the background color and the default user. Hello, default user. Welcome to K8's Kadence, which will be showing pretty much on the same pod itself. But as you see, I just curled the name of the service. And let me see here. Okay. If I cancel this and exit, which it showed, but I don't have time to like troubleshoot it enough, for the purpose of this. But essentially, what the service is doing is it's exposing those two pods because the service itself doesn't have a deployment or anything. It's just saying, okay, when you hit this endpoint, when you hit my service name, go ahead and run this, provide the information that's on that port 5000 on that pod. So hopefully that explained that. I wish I was able to get that portion working. I guess that was the firework of the night, which failed, of course, for demos purposes. It had to. It wouldn't be fitting. Idris, you probably know the solution to this. What's up?
I think the reason why you guys might be experiencing the pull back off is because the operating system the image was built on might be different from the operating system that you're running it on. So let's say the OS that is used to build the Docker image is Linux, right? And someone is using a Windows system to kind of run the image or to kind of test the image, and they will run into this issue where they're getting this exec format error and other like errors like this.
Gotcha.
So
See,
that's why the solution would be to kind of build like the multi-platform Docker image whereby it supports multiple
OS.
OS.
Uh-huh. Gotcha. Yeah, I couldn't experience um a like I only have a Mac, so and it's kind of interesting that you bring that up because Docker is supposed to for the most part kind of like rectify that type of issue, but obviously it's scoped to like dependencies. But yeah, I haven't been able to successfully test that, so I'm not sure what operating system you're using, Cisco. But good point, Idris.
I'll push my own image to my own GitHub account and use my image.
Oh, and it still give you the same issue?
No. I'll try it now. I'll try to
Oh,
build
okay,
my.
okay,
I'll push
okay.
my image that I build locally. I'll push it to my GitHub account and just see where I go from there.
Yeah. See if that that fixes it for you.
Okay,
Um,
I'll do that.
Perfect. But
Because
yeah,
I switched the version. I went to version 3, same issue.
oh, same version. Yeah, okay. Yeah, that's interesting. I really want to know why this kind, because I had to do some research on it, and it's part of the kind configuration. So let me do kind, and let me see what uh export one of the cube configs, load version. I have to look at it at another time. But yeah, it should have been able to get me there. Be able to failures, give me a failure. Super weird. Um, infinite 30,000, 30,000 is still doing the same. Um, 3001, yeah. But that's pretty much it for the session today. I know we kind of went over. This was like a super long, like session. And yeah, I know there's a lot of stuff to go over and to discuss, but once I figure out what's going on with that deployment stuff, we'll come back and look at it and make some other changes so you can see the value of it. But right now, that's pretty much all I add today. If anyone else has any like questions or anything like that, feel free to, like let me know. And this is your time. So we can wrap it up at 10 p.m. to, if anything. But I hope you guys learned something or at least enjoyed it, and I wasn't hopefully like rambling off too much.
It
And
was a great session. It was very interactive. It
awesome.
was
Well,
great. It was great. And by the way, Patrick,
yeah.
Cisco is also a Kubernetes guru, even though he's acting like he doesn't. He is a guru, believe me, Idris. So the idea is that we want everybody to be CKA certified, right?
Yes.
That was
Right.
the main, that was your main goal, and I'm seconding that. And I think that we'll get there, all of us, right? So that's the agenda, to get
Yeah.
everybody certified, and also actually do these demos such that they replicate like real work,
Hmm.
and real life troubleshooting stuff like that. So this is great, and it was great seeing some new people here. It's just really good.
Yeah, yeah. This is actually our biggest amount of people to show up. So I'm usually used to like 3 or 4 or 5 people. So to see 20 people on here 2 hours in and still here, I'm like in shock and in disbelief to be honest. But I'm excited for you all who's invested in and interested in learning. And we have quite a bit of experts. Again, I do not consider myself an expert, but we do have quite a bit of skilled people here. Desiree, he's like a freaking he should been taking this exam. He should have took it the same day I took it. But no rush. And he's been here with me, from the beginning. And as far as
Nice.
other people too. I know Brent, he's kind of, just had some opportunity and some time and he's on his own learning. But all who've joined, I really, really appreciate it. And let me know how we're doing, how we can improve. I know Edis was interested in talking about ingresses, so we can save that for next time. But yeah, let me know exactly what you're struggling with, what you're interested in, and we can kind of again tailor this for you because this is for you all. So that this is the main point of that I'm trying to emphasize. And I think someone just raised their hand. Let me see the queue. Um, okay. Olu,
Yeah, I just say Elijah. I think that should be
Elijah.
the name
Okay.
looks. Yeah, yeah, that's fine. From my point of view, I had followed up from the start up until now.
Yeah.
I've been doing my self-study through Cold Cloud,
Okay.
and like I've learned so many things. But I just didn't have structure like because I needed a real live project that I can actually channel those things to. With Code Cloud, they kind of give you those hands-on, like
Yeah.
the tools that you need to know. You get to see how they work, but sometimes you just don't see how they connect, just like you kind of like showed deploying an application and stuff like that. So I don't know
I
how
think
this can, yeah, how you can actually manage.
I think
The
this platform that Mr. Patrick is kind of running is gonna show you like an example of a real world projects. And some people that also reach out to me, I usually ask them to research VI GitHub to see like applications that people that like open source out there, and try to see if they can start by containerizing those the application, and using Kubernetes to deploy those image, because there are projects around you. You just have to kind of research and find project on GitHub.
Yeah. No, that's a great tip.
yeah, yeah,
Um, but yeah, that's a great tip as far as looking around and finding the real world things, because I had the same experience with Code Cloud. It's really good as far as to get you to understanding the process of everything. But sometimes you want to, see, okay, how am I gonna build this stuff? What am I really containerizing? They have all these type of scenarios. So my whole plan with this is for us to start here. I know Edis is really good at Python, so I just joined his session earlier, and if you guys haven't joined, his session is really amazing. As far as if you're looking to learn Python, he's creating right now a as far like a store using Flask, which is pretty cool. You can build things like that, and you can dockerize it, and you can containerize it, and then you can host that on Kubernetes. So if you were really looking to have some real world stuff, there's a lot of things that you can do. But this is the best way to learn. The code cloud kind of limits you, where they create, for example, how to do a rolling deployment, or how to do like a blue green deployment. I can show you how to do a blue green deployment by us using those versions 1, version 2s, and version 3s, and by using a selector in the label. So that's kind of where we're going to get to. So this is obviously day 1 or day 0 really. But yeah, we can definitely build, and again, all the feedback that we get from you all, we can kind of reinforce the learning, starting with this application, and then build it to something else. I don't even know where it's going to be at the end of it. So we can use all your creativity and all your minds to create those scenarios for us, so we're prepared for the real world, and then the exam is just going to be a icing on the cake.
Great stuff. Thank you.
Oh, thank you. And Michelle.
Yeah, hey guys, sorry.
Hi.
Um, I just enjoyed this section. Honestly, Engineer Idris is like my mentor, so I work with him. He invited me to this section today, and I really like how I think it's Patrick. Sorry,
Yeah.
I call everybody engineers. I just don't like to. So Engineer Patrick, and then someone would chime in and then also help with like answering the questions. So it kind of gave me a pretty good understanding. So on top of what I'm learning with Engineer Idris, you're never done learning in this DevOps. So slowly, it's slowly coming together. So I just wanted to say I enjoyed this section.
Oh, well, thank you, and we really appreciate your feedback. And again, this is just not a session where I talk to you, or anyone that feels they have a question or they want to chime in. Feel free to. Again, I'm also learning this stuff as we speak. So me doing this is pretty much just going through and through with you all, and that's kind of where this even originated from in the first place. So this is a safe space where we can all learn and build each other up, because we need more like us here. And yeah, we need to get certified at the end of the day, so we can
Mhm.
show that we have those skills.
Yes, thank you.
Thank you. um but good stuff, good stuff. Does anyone else have anything?
Hey
Not
Pat.
for here. Oh, I'm sorry. Go ahead.
Yeah, Pat, this was an amazing session, man. You described it pretty well here. I had a question earlier, but
Oh,
I just didn't want to ask it right away, just in case you would go over it later on. And
mhm.
it's on setting up your cluster. I know in this case we're running it on one VM, which is gonna be, well, in your case you're running it on your laptop. I'm
Mhm.
running it on a VM. Is there any scenario where we would run it on multiple VMs? And in that case, how would we connect those?
Ah, good question. Where there's this tool called CubeADM, where that's what initializes and creates a Kubernetes node itself, right?
Nope.
So and yeah, it's every Wednesday. So yeah, it won't be a session tomorrow. But next Wednesday we can definitely chop it up and talk further from there. And build for, so it'll be next week, and I'll send you all it's the same link. It's a static link. So before I was giving like, different links every message and every meeting. So it'll be the same link that you guys click today is the same one that you'll be able to access at 8 p.m. Next Wednesday. So just keep that in mind. But to your question, Desiree, it's something, a service called, or a tool called CubeADM, and with that, you're able to create your clusters. That's how you can have. I can have a computer right here. I can connect to your computer. I can have a node or inside, GKE, like Cisco was using, and all those can still be technically in the same cluster as long as they have like connectivity and stuff. But what it does is it creates a. Let me show you in the Kubernetes documentation here. Cube ADM, and then I'm gonna put the join. Um, so you create a cluster with Cube ADM, and then there's this thing like called a join token. So let me find where it says join. I know it's somewhere over here.
So with that, you'll be able to control it all from the same control plane.
Yeah, so from that, because the control plane, you run this command on the control plane, and it will be able to link them together. So when you do the kubectl join command, it should be somewhere, man. Where is it?
It's kind of hard to find the documentation. I actually
Yeah.
set it up before, but it's kind of hard to like find those documentation. I had to go to a GitHub. I might have that GitHub. Let me look for it.
It's in here. Trust me, I'm gonna find it right here. Let me
Oh, there you
find
go.
Is it um damn it, where is it? No, kubectl, because there's like a flag that you can run, and it actually gives you the command. Um
All right.
where is it? Kubadium join. And I'm probably using the wrong like keyword, but there's a command that allows you to like it does it for you. It creates the join command. All you gotta do is literally copy and paste it into the worker node, and then that worker node was automatically going to join to the cluster. I don't know why I can't find it right here, but it's a very easy, it's a lot easier way to do it. Oh, it's token. I know it's like token or something like that, but of course in the heat of the
Have you had
moment.
a chance to run it in the past?
Yeah, I was able to join a few. Now, um Kubium join control token.
Curious how that's gonna work in the cloud, having it run on two different VMs.
Is it join discover token?
Is that what it is? It's one of those things. Yeah, I can't find it now, but it's on one of
I'm
these pages.
yeah, I think I found it. I know, like I said, discover. It's like that discover token.
Yeah. And then you just paste that in there, and then it also creates the hash for you. So you're just pasting it in there. So it's pretty much the token. So it once that's in there, it automatically is gonna say, okay, this node is joined, and you'll be good to go. So you can have a different clusters, because that's kind of what for example, EKS Anywhere is. Not sure if anyone is familiar with that, but that's um AWS Elastic Container Service anywhere, so you can have it. You can have a cluster running locally in your, as far as in your on-prem, and that can still communicate with the cluster in AWS. So you may have an EKS cluster running. You can still have bare metal locally on your on-prem, and that can still communicate and talk, just as like an option. So you don't. It's not necessarily like scoped down to only somewhere where you're like locally or only within the cloud. You can still kind of have a hybrid type of setup,
Okay.
especially if you've invested in some type of hardware and um,
Does
you
the
know
token somehow sorry to interrupt you.
yeah,
Does the
yeah.
token somehow know the IP address of the other VM?
I haven't tried it in that as far as in that scenario. I don't know what the security settings and stuff have to be related to that, because I know, for example, um like EK, and I'm AWS focused, so I can't really speak for other
I
for
can
other providers, but
I can speak. I think I speak on it. It has to be within the same network. Like you can't have it to
okay,
where there
yeah,
are two different, like I think unless you have it like linked like a site to site VPN. It has to be within the same
Okay.
network. I just
I
know
mean,
that from experience.
okay,
Try to it's kind of like you trying to um put a token from. But yeah, 'cause it has to be within the same network because that's the way to where they can communicate is through the IP address. And
yeah, no, yeah,
go ahead.
no, I didn't mean to interrupt. I'm sorry.
Oh well, yeah, it pretty much it used like because I do know they use like the proxy, which in a sense is still using the IP address. The IP address, from what I understand, is still the basis of how it communicates. It's almost kind of like how also I think Ansible also works the same way. So you have to still use a particular token or you have to pretty much use the SSH file to provide the key for that, but
Yeah.
without that particular key, without a particular key or an IP address referencing that key, it won't be able to communicate. From what I
I see what
understand.
you're saying. I see what you're saying.
I think it needs to have kubelet, the agent installed.
Yeah, you definitely have to have Kubernetes agent installed.
Yeah,
Yeah.
like
So
to join it because we have the documentation here to do it using the Kube ADM init stuff. You need to have all the agents installed on all the other um nodes, right?
Which I
Yes,
believe
And
QADM does install those for you.
I think the QADM installed the kubelet on the master, but you still on the worker
on
node still
the
have to install.
exactly
yeah.
on the other worker nodes.
Yeah.
Yeah,
Hmm.
you need
On the
those
worker
on
node,
there.
you still have to install the kubelet, and I think the proxy too. I'm not sure the kubelet install the kubelet and the proxy. I can't remember, but I do know you have to at least have those two installed on worker nodes in order for everything to work properly.
Yeah, you got to
Yep,
install
the
kubectl
kubelet,
on the other node.
kubectl and kubelet.
Yeah.
Yep.
Hmm. But yeah, but great questions. But yeah, we can definitely, as far as like go in a deeper dive. I actually didn't have this expectation as far as the how much we were going to progress today. This is just like this is like a pilot as far as what me and Anderson was talking about. So I'm trying to tailor it a little bit more of like a syllabus, so it's a little bit more formal and as far as the progression that we're making it. So what I would recommend for those though is if you are able to at least do some like self-studying, go on the documentation, like go on the website, look at what they're talking about. You can get a lot of information from the source. They built this thing in and out. So just look at that. If there are certain like topics that you are struggling with, definitely YouTube. I have my own YouTube here that you can follow and watch. And definitely just try to be a little bit prepared for the next meeting and come with your questions. So whatever you do find that you're having like trouble understanding, we can go ahead and as far as do a deeper dive into it. So it's a little bit more value in your time, especially when you're coming to spend your time with me. So I want to make sure you guys are getting the best value.
Sorry, Patrick, what is your YouTube channel again? What's the name?
Oh, I didn't. Yeah, I don't think I shared that. It is if it's on YouTube. Let me just give you the link here.
Okay.
I guess a weird number thing here. So I'll send that over. Here you go. All right. And if you guys haven't already, love if you guys subscribe and like. And this session is also going to be posted on YouTube as well, raw and unfiltered. So all of my I'm gonna back watch this and see how many times I was trying to say pod and say container. It happens all the time. But the format that I like. And yeah, again, watch those videos, and if there's anything else that we can do and help, you can post in the Black Cloud Geeks Kubernetes chat, or in the DevOps community that we're in, that I recently joined as well, that most of you guys are in the DevOps Full Stack AI Agile group on WhatsApp. So you'll get all the updates through there. And we also just added a chat directly for Kubernetes, so we're not like cluttering up the main channel, the main chat there. Um, but that's pretty much it for me. My dog's kind of hungry now, so I hope you all enjoyed the session tonight, and I really, really appreciate you all, staying tuned and being, investing your time, and also as far as like, interacting with me as well. So that's my favorite part of tonight. So thank you all again. Come with your questions, and go and break something like on a computer, not anything.
Thank you. I already subscribed to your YouTube, so
Okay, awesome. Thank you.
Hey Patrick,
okay then.
Cisco just posted those bookmarks thing that we looked at the other day. So everybody might want to get that. Not this one, the
Okay.
bookmarks.
the bookmarks. Oh, okay,
Yeah,
yeah,
right
actually.
there. This is a great
Oh,
resource
yeah.
for
Okay.
everybody to have it to
Yeah, I'm gonna
install.
save this. So yeah, they have a bookmark of like every type of like services, like the Cube API page. So yeah, it gives you like all the commands that you are gonna most likely use, practice tests, how to install Cube ADM and like what a replica set is, why namespaces, what is a
Oh,
namespace.
oh
He,
yeah. You drop
he
that in the chat like now.
yeah,
I
he got
need
it in the
that.
chat. It's in the chat. It's
Oh,
right here. It's this one right
where is it
here.
at? Oh,
It's
okay. I see it now.
yeah,
Good. Let me
yeah, it's
put that in
right
my
there.
bookmark.
Thanks Anderson and Cisco for
No
posting that.
problem, man. Hey, I
Um,
see Terrell here, man.
oh, he's in here?
Yeah,
No, I
he's
think he
right
left.
there.
He dropped. He
Oh,
dropped.
he left. Got it,
Yeah,
got it,
it's in the drop. He's in the drop section. He said he had to leave a
got
little
it,
bit earlier.
got it, got it.
Um,
Okay.
but yeah,
Great stuff,
he's
man.
he's he's definitely gonna be he joins the sessions all the time. So you can speak to him and then we can see how we can get him into the other group. Show some love.
No
But
problem.
that's it for me. You guys have a great night. Good morning. I'm not really sure what time zone everyone is in, but continue learning and definitely looking forward to see you guys next week, 8 p.m. Eastern.
Yes,
All right.
sir. Thank you,
Thank
sir.
you,
All right.
guys. And
Thank
you
you.
guys should join Engineer Idris class on Python. It's pretty good.
Yes,
Can you?
definitely.
Absolutely.
There's like a group chat for that,
I
or
think
Hold on.
Engineer
I did.
Idris, I think
He
he's in.
usually posted on DevOps Full Stack Forum. Let
I
me
don't think I'm in
post
there. I'm on
that.
the Black Blue Lab. I'm not in the DevOps one.
I'll send it to you. I'll make sure that you
Yeah,
get a copy of it, bro.
Okay, cool.
Okay.
yeah.
Appreciate you,
Yeah,
man.
I'll send it right
All
over.
right.
So don't worry, Anderson. I got him.
No
Thanks for
problem.
everything tonight, Pat.
All right, thank you as well, Desiree. You guys have a
All right.
great night, and again, shoot me all the questions you have, so we can definitely have them prepared for next week, so we know exactly what you guys are looking for.
All right.
Perfect.
Thanks,
All right,
Pat.
Thank you.
thank you.
All right. Bye.
All right.